Hi everybody, we're doing another example of solving a differential equation with variation of parameters. So we're looking at the differential equation x ln x times y prime plus y equals 2 ln x. So the first thing we do is we take that and we put it into whatever form, what do you call that, we get a y prime without a coefficient. So we're dividing everything by x ln x, and that turns it into this. Now our p is going to be 1 over x times ln x, and q is going to be 2 over x. Just bear that in mind. Anyway, now we look at the corresponding homogeneous differential equation. That's y prime plus 1 over x ln x y equals 0. And we solve this corresponding differential equation with separation of variables, and we get dy over y equals negative dx over x ln x. This we could just integrate straight and we get ln y. This guy, we got to do a U substitution. U equals ln x, du equals negative dx over x. And we have the integral of negative du over u, which is negative ln u, which is negative ln x. So it's ln x. It's a double ln of a ln. And now we have ln y is equal to negative ln x plus c, and y is equal, which gives us y equals k over ln x, because we exponentiate both sides, but y1 is just going to be 1 over ln x. We don't need the k. I guess that it could have got rid. I didn't really need the c either, but whatever. y1 is 1 over k. Now is where we substitute everything. So now is where we create the variable. Not the u that I use up here, but the u that we use for variation parameters. So we create the function u of x, and y equals u times y1, which is u times 1 over ln x, because that's what y1 is. Now we take the derivative with product rules, so y prime is equal to u prime over ln x minus u over x ln x squared. That's just doing basic calculus. And now we plug this into our original equation, so x ln x times y prime becomes x ln, because that was the original equation, x ln x times y prime plus y equals 2 ln x. So x ln x times y prime becomes x ln x times y prime times u prime over ln x minus u over x ln x squared plus y, which is u over ln x, which is there, got that right there, and that's all equals 2 ln x, which is what we had originally up on top. Now I'm just going to distribute here, so I get this becomes, when I distribute, this becomes x u prime minus u over ln x, and I have I just bring down the plus u over ln x. Notice that these two very conveniently cancel. Isn't that nice of them to cancel out so nicely and conveniently? And which just gives me x u prime equals 2 ln x, which means u prime equals 2 ln x over x. And this also, this is also very easy to differentiate, U substitution, and I get u equals ln x squared. Not the ln of x squared, but ln of x in parentheses, the whole thing squared. And then, of course, plus c. So now my final answer, y is equal to u times y1, which winds up being ln x squared plus c over ln x. Or I could separate this as ln x plus c over ln x. And that is my final answer. That's the y. So that's the solution. We have solved the differential equation. Yay!